Hi, let me clear this area. So what we're going to do is to examine the power of an element in frequency domain. We know the instantaneous power of an element in frequency domain is the multiplication of the voltage and current of the element. On the other hand, we know that in frequency domain all the sources are sinusoidal functions. Since the independent sources are sinusoidal functions, then the particular solution which we find in frequency domain is also a sinusoidal function in the form of the source function. In this sinusoidal function, frequency do not change. That means that omega is the same as the source function frequency. What is changing is that maximum power of maximum value of the power Vm and the angle of it, and maximum current Im and the angle of it. So what is our aim is to find the average power. That is the instantaneous power. We change with time. So if we get the average, then we can transfer it to the energy. So finally we are going to calculate the energy from that power. So just remind you a few mathematical operations between the relation of integral of a function and the result of the integral. So what I am saying is this. So assume that you have a PF function, PT function, sorry, and make it freehand. So PT function, that's the power, instantaneous power, that's time. And assume that there is a function changes like that. This is power function, starts from 0. So if you take the interval of this, let me do it here, dt, from 0 to capital T. Assume that that is capital T. So this integral results is the area underneath this here, so underneath the function, this area is the result of that integral. We can look at this integral, the result of this integral in another way. What is this area? Can we calculate this area? Another way of saying the calculation of this area, make a different column. So it's going to be consider this now. So that is, I'm going to show it to you, that is the average power, P average. I'm going to show it why it is average. So that is, keep the color as it is. So that is the capital T. So if I ask you, what is the area underneath that curve? This second one, that's this curve. Okay, so this area is the average power, because you are representing all these curve with just a constant and multiply that with t. So this area is the same as this area. If it is so, then this is equal P average time capital T. So from that, P average is equal 1 over T integral 0 capital T pt dt. So that's the conclusion that we can get. We are saying the average power, if you have any function, then you can find the average of this function. How are you going to find it? Integral of this function and divide it with the time interval that you integrate. So that is capital T. So you're going to divide it to T, capital T. Then that gives you the average power. So that is our average. So if you come to the energy now, energy is the integral of Pt dt from 0 to T. So make it a bit. Open that area. Energy St is equal to this. But if you have the average power, so what is the average energy that you're going to calculate? You're going to put average here, 0 T P T average. That is this one. We know P average is a constant, isn't it? dt. So it becomes P average times 0 capital T Pt dt. So no Pt, of course, we put the Pt outside. Why is that? Because if it is constant, you can take it out of the integral. So that the result of this integral gives you T. That means P average time T gives me the energy. That's why P average is important. So if you transfer it to the sinusoidal function now, if it is Pt is a sinusoidal function, multiplication of this is going to end up with the sinusoidal function. So you're going to find the average of this Pt, that means instantaneous power, and then multiplied it with the period. How many times you have the period, isn't it? If it's 0.2, it is for one period. If you just say that 10 period time, you're going to multiply it 110t. So that is simple then to getting the interval. So once you know the average power. So that's why the average power is important. Our aim now is to find the average power. How are we going to find that? So if you look at this now, we've got two sinusoidal functions, but each of them has got an angle. But we can transfer this angle, one of the variable angle, let's say current angle, to make it 0, and change that angle of the voltage. This is going to be useful for us to do the mathematical operations that we're going to do later on. Can we do it? How we can do it? That's easy. Assume that that's independent current source. So this current, if I put an independent current source here, of which current is equal to this, then you can easily say that this element current is the same as independent current source current, isn't it? Why is that? Because for this node, Kirchhoff current law equation tells us this current equal to this one. So this element current is this. On the other hand, what we know in mathematics, make it a black color now. So what we are doing in a frequency domain, find the phasors in this form, isn't it? Ix equal to V. These are linear equations, and the coefficient is going to be complex coefficient. So from that, you can say all the unknowns is going to be this, isn't it? Minus 1b. B includes independent source phasors. So what does this mean? If there is a phasor here, that means it has got a module, let's say d, and an angle, let's say j via theta s. What happens is this: you're going to do a calculation. At the end, each unknown's angle is going to be added to that source, or you can say it the other way around. Each current and voltage unknowns angle at the end will be added to this theta s. So if you make that theta s equal to 0, that means at the beginning you can change the you can make the 0 time as the beginning. That means when the theta is equal to 0, assume that that is 0 time. So if you could do so, that means you're going to shift this. You're going to add minus theta e, so you're going to shift this function to the right hand side, and if it is minus, you're going to shift it to right. So if you shift this one, you're going to shift all the others element voltages and currents. That means you're going to shift this one as well. So you're going to shift both of these by minus theta e. So nothing will change because our functions are periodic functions. If you do so, what happens? This it becomes Im cos omega t. That's one. So what we have done here, it was like that, and we add minus theta e here, then it became Im cos omega t. Similar thing is going to be for the voltage here. That means that one. Vm cos omega t plus theta v here, and we are going to subtract that minus theta e. You end up with Vm cosine omega t plus theta v minus theta e. So that means this is phase difference between the voltage and current. What happened is this: instead of using these two element current and voltages, if I shift one of them to the right hand side by this minus theta e, I'm going to shift all the elements current and voltages. That way you end up with the same result, because when they are shifting a periodical signal, once again you're getting a periodical signal. So that conclusion is going to be used in the future. So what does this mean in practice? Shifting. When I say shifting, make it a bit clearer. That's minus. We are talking about this. For example, you've got a blue one here, and that's a cosine function. So if you add, this is different from the previous one, if you add an angle to that, that is plus theta. If it is plus, it is shifted left. If it is minus, it will be shifted to the right. So the one previously we had, make it a different color, make a blue, we also can make it red. So what is going to happen if you minus theta is going to be like that. Goes on like that. This one shifted to the right. Shift right minus, that is theta. If it is plus theta, it is that brown one. blue, if you put it minus here, that means this one, cos omega t minus theta. So this is the red one. So if it is minus, that blue shifted to the right. If it is plus, it shifted to the right. So what I have done is this. So if you do that shift business, you end up with a result saying that we can consider the current of this element as this, voltage as this. So instantaneous power becomes this, multiplication of those two. From that we are going to find the average power. That's why what we have done here. So in conclusion, what we can say, we can transfer these two currents, this current and voltage pair, to this one. If the signal is sinusoidal, we are shifting the source minus theta e, so all the elements current and voltage is shifted to minus theta e. We end up with this. So average of this is going to be the same as the average of this. It doesn't make any difference because we are going to find the average for a period. So that's the end of this video.